This video covers Mo-Sys VP Pro XR, a cinematic LED content server system designed to drive LED volumes with or without set extensions. Here you can see an LED volume with set extensions, otherwise called XR. The use of LED volumes isn't new. The current wave of adoption, which started in early 2020, used live event LED tiles and media servers because this was the only option available at the time. Today, the industry is rapidly moving towards using LED volumes built to cinematic quality standards. Here's the same LED volume with set extensions, but now with additional AR foreground elements to enhance the illusion. This whole virtual scene is being powered by Mo-Sys VP Pro XR, which has been purpose-designed for LED virtual production by film and broadcast specialists with over 25 years of VP experience. In this video, we'll cover the main features of VP Pro XR. However, other key features of VP Pro XR are covered in companion videos, namely Cinematic XR Focus for putting focus between real and virtual elements, multicam switching, enabling 2 or more cameras to switch at UHD 4K resolution without the LED wall delay in shot, near time, an auto re-renderer for increasing virtual scene quality, and Digital Stars, a collaboration with Brompton that places digital tracking markers on the LED volume which aren't seen by the camera. Here's an animation showing the elements involved in an XR studio. In the middle is a visual representation of the set extension, and on the left is a rack containing VP Pro XR. Hard and soft lighting is used to supplement the color gamut of the volume. Before you can use an LED volume, you need to map the physical dimensions of the LED volume to the virtual 3D scene being used. This is called mesh mapping. Because Mo-Sys manufactures both the Star Tracker camera tracking system and the VP Pro XR LED content server, mesh mapping is made much easier. For straight LED walls, you simply need to point the physical camera at 3 of the 4 corners, and the system will map the LED wall to the virtual scene. For curved LED walls, the same tools can be used, but this first requires that a LiDAR scan or a CAD diagram of the wall shape is imported first. Once the LED wall has been mesh mapped, it's possible to add the set extensions and any AR elements required. Here's a scene with set extensions, creating the illusion of a much larger set than we actually have. The red outline shows the extent of the LED wall and where the set extensions join. We need an AR element added to the scene to cover the book sitting on the box to create the illusion of interaction between the talent, the book, and the virtual scene. Here's the same scene in 2 versions. The one on the left has no set extensions or AR. The one on the right has both set extensions and AR. Notice how the one on the right creates the illusion of a much larger set, and how the additional AR element creates the illusion of a bookshelf. Here's one of our virtual scenes with a set extension added on the right hand side. If we remove the set extension, you can see the extent of the LED wall. To make set extensions appear seamlessly joined to the LED wall, we need to color match them to the LED wall. If we now bring back the set extension and speed up the sequence, you can see how the operator can use VP Pro XR's color correction toolset to match the set extension to the LED wall. This same toolset can be used with the AR front scene component to match this to the rest of the virtual scene. VP Pro XR also offers color bars and test patterns which can be brought up on both the LED wall and the set extension to aid color matching if required. Delay is a significant problem with XR production. The delay is generated by the cumulative time taken for tracking data to reach the graphics engine, the engine to create the correct scene perspective, and for this to be displayed on the LED volume. In the animation, you can see exactly where the delay is generated. With VP Pro XR, we remove the need for a media server. Delay impacts an XR shoot by reducing the speed at which cameras can be panned. Panning too fast causes an obvious break in the illusion of the set extension. In some cases, if the camera pan is too fast, the image on the LED volume becomes juddery as the processing tries to keep up, but fails and drops frames as a result. VP Pro XR introduces just 7 frames of delay, which combined with the LED processor delay of 2 frames, gives just 9 frames total. This is low enough to pan at a reasonable speed without seeing the virtual image judder or the set extension illusion break. In this side-by-side example, which we slow down to show the difference, you can see how VP Pro XR with its minimal delay on the right enables a camera pan where the virtual scene keeps up with the pan. On the left is what typically happens with a media server not optimized for XR production. For more information on VP Pro XR or to view companion videos showing other VP Pro XR features such as Cinematic XR Focus, multicam switching, near time or digital stars, please visit the Mo-Sys website.